Hello everyone and welcome back to my YouTube channel. Myself Prasanna Mista, studying in Sri Venkateswara College of Engineering, pursuing my BE in CSCCY Cybersecurity. Today in this video we are going to discuss about the topic K-maps and its advantages and disadvantages. First, introduction to K-maps. Karnaug maps, commonly known as K-maps, are visual tools used in digital logic design to simplify Boolean expressions. They provide a systematic and initiative method of minimizing the number of logic gates required to implement a given function, resulting in more efficient and cost-effective designs. Now, let us see the definition of K-maps. A K-map is a graphical representation of a truth table. It arranges the min terms or max terms of a Boolean function in a grid format, where each cell corresponds to a unique combination of input variables. The arrangement of cells is based on Greek code pattern, ensuring the adjacent cells differ by only one variable. This arrangement allows for the easy identifications of groups of adjacent cells which represent implicants or implicates of the function. Min terms. Min terms represent a product term of all input variables where each variable appears either as a literal or its complement. They correspond to a specific rows in the truth table where the output is true. Max terms. Max terms represent a sum term of all input variables, where each variable appears either as a literal or its complement. They correspond to a specific row in the truth table where the output is false. Next, advantages of K-maps. K-map offers several advantages over traditional algebraic simplification methods, making them a valuable tool for digital logic designers. First, simplicity. K-maps provide a straightforward and visual approach to simplification, reducing the need for complex algebraic manipulation. Second, efficiency. They enable rapid identification of implicants and implicates, leading the efficient minimization of Boolean expression. Third, minimization. They help minimize the number of logic gates required to implement a function, resulting in smaller, more efficient circuits. 4. Flexibility. They are adaptable to various Boolean functions regardless of their size or complexity. Next, disadvantages of K-maps. While K-maps are powerful tools and they also have some limitations. First, limited size. K-maps became increasingly complex and difficult to use for functions with a large number of variables. The size of the map grows exponentially with the number of inputs. Second, don't care conditions. While K-maps can handle don't care condition, it will be challenging to incorporate them efficiently, especially in larger maps. Time complexity. For highly complex functions, the time required to manually simplify using K-maps can be considerably, especially for beginners. Next, simplification of Boolean expressions using K-maps. The process of simplifying Boolean expression using K-maps involves several steps, all focused on identifying and combining groups of adjacent cells representing implicants or implicates. There are four major steps. First, construct the K-map. Create a K-map corresponding to the number of input variables. Each cell represents a unique minterm or maxterm, and the arrangement follows a gray code pattern. Second, fill the K-map. Fill the K-map with ones or zeros based on the truth table of the function. A1 indicates a minterm that produces a true input, while a 0 represents a minterm that produces a false output. Third, identify groups. Identify groups of adjacent cells containing ones. Groups can be horizontal, vertical, or diagonal, and they must have a power of 2 number of cells, 1, 2, 4, 8, etc. 4. Write the sum of products expression. For each group, write the corresponding product term by identifying the common literals among the cells in the group. Combine the product terms using OR operator to create the simplified sum of products expression. Next, visualization of Boolean function using K-maps. K-maps provide a clear and intuitive visual representation of Boolean functions, allowing for easier analysis and understanding of their behavior. First, mapping truth tables. K-maps directly represent the truth table, highlighting the relationships between input combination and output values. Second, identifying patterns. The arrangement of cells and the grouping of adjacent cells with ones reveal patterns in the function, making it easier to understand how the output is determined based on the input. Third, simplifying complexity. By grouping adjacent cells, K-maps simply complex Boolean expression into smaller, more manageable forms, enhancing comprehension and making it easier to implement the function using logic gates. Next, applications of K-maps. K-map finds application in various areas of digital logic design and related fields. First, digital circuit design. K-maps are extensively used for designing and minimizing logic circuits in digital systems such as computers, microprocessors, and other electronic devices. Second, data processing. They are employed in data processing applications such as implementing logic functions for data manipulation and control flow. Third, logic optimization. K-maps are valuable tools for optimizing logic expressions in various applications such as digital signal processing, control system, and artificial intelligence. Last, digital system verification. They are used in verifying the correctness of the digital design by comparing the simplified expression obtained from a K-map to the original design. Next, conclusion and key takeaways. K-maps provide a valuable tool for simplifying Boolean expression and minimizing the complexity of logic circuits. They offer a visual and intuitive approach that enhances in understanding and efficiency in digital logic design. However, it is essential to consider their limitation, particularly for large-scale and complex problems. As technology continues to advance, other methods and software tools are emerging to address these challenges and provide even more efficient solutions for digital logic optimization. Thank you for watching my video. Please like and share the video.